Alrighty, so part two. Do, 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 do. I was just finishing the last one, and now I guess I have to do this one. Okay, minimum pair removal part of to sort array part 2. Given an array nums, you can perform the following operations. Select adjacent pair minimum. If such as array exists, choose leftmost one, replace the pair. Okay, that's exactly like the previous daily. Return the minimum number of operations needed to make the array non-decreasing. An array is said to be non-decreasing if each element is greater than the previous. Okay. So what to do? Hmm. 1 second here. Very interesting. All right. So let's see. Um, how to actually do this quickly. So this thing is now 10 to the 5th rather than, I think it was like 50 last time. And the values are bigger. So I think 10 to the 5th is definitely not doable with the approach previously, which was n squared. 10 to the 5th and 10 to the 5th would be 10 to the 10th, which is 10 billion. It should be doable with something like an n log n, or linear, obviously, speed algorithm. So I don't think this should be linear. Well, maybe it is linear. So let's go ahead and consider this. So 5, 2, 3, 1, 10. If I were to do like a heap, which is going to be linear, or it's going to be n log n time, since heap requires sorting pretty much. This should be like 7. Let's say the heap should have the storage of the sum and then the index. So 7, 1, 5, 2, 4, 3, oh, 5, 0, no, this should be 7, 0, 5, 1, 4, 2, like 11, 3. So I take the lowest sum off the heap. and then I need to somehow replace it, right? This thing needs to become a 4. 4 logically, but 5, 5, 2, 4, 10. I wonder if I can do a linked list. So if it's 4, 2, I wonder if I can do a linked list. Each index keeps a link, keeps a reference to. I have a list, a linked list of. How would that work? How would that work? Each node is the pair that I'm dealing with. Each node is the pair that I'm dealing with. I have a reference to the node in the tuple. That seems kind of ridiculous. But maybe it. Maybe it is. I have a node 4, 2. Can I have a heap of nodes? Is that doable? So when I modify a node, it has a reference to the next node and the previous node. Where the nodes again are the pairs, right? But then I'd have to remove the nodes. Remove the nodes. Would that work? Would that work? 7, 0, 5, 1, 4, 2, 11, 3. Remove nodes. So if I were to have a node 4, 3, 1, so it's 4, 2, which is the lowest node in kind of the lowest node in the heap, the lowest pair sum. And then take that node off the heap. The node has a reference to the previous pair and the later pair. And then I modify those two. So I modify those nodes. But when I modify those nodes, I need to re-add them to the heap. Re-add their adjusted values to the heap. So like 4 is replacing here. I wonder if I even need indices. I guess I need indices as a tiebreaker. So anyways, so 2 becomes, so it looks at the previous node, which was previously a 5. I think maybe, okay, I think I actually do need to keep track of just everything. So 0, 7, 0, 5, 2. So each tuple is like, it's kind of a node, which is going to correspond to the sum index value 1, value 2. I need to know all those things. 5, which is index 1, 2, 3. 4, which is index 2, 3, 1. And 11, which is index 3, 1, 10. So if I were to take the smallest tuple from the heap, and then it has a reference to its prior node, prior pair sum. So then it looks at that, and it sees that the sum is 5 from a 2, 3, and the 2, 3 is going to be modified to become a 2, 4. So then it's going to replace that with a 6, 1, 2, 4. And then it looks at the later one and says 11, where the 3 is coming from it. That needs to be changed to a 4. So it's going to become like 3 to 4, or no, it's 1 to 4. So it's 3 more, so it's like 14, 3, 1, 4, 10. And then there's still a node that is 7, 0, 5, 2. That's not changed. And then I need to add those tuples into the heap and somehow register that these previous tuples are no longer valid. Ten to the fifth. There might be 10 to the fifth tuples in the heap, at least. And then what am I tracking? I'm tracking the number of non-decreasing elements, or the number of decreasing elements. So tracking that 3, 1 is a decreasing element and 5, 2 is a decreasing element. So I'm tracking 5, 2 is a decreasing element, 3, 1 is a decreasing element, so it needs to remove at least 2 decreasing elements. In theory, it could possibly be more, right? Like, could it be? Could I somehow do some sort of combining and cause more decreasing elements to form? Maybe I need to keep track of that variation. Okay. So I think I need a decreasing count. Let's say I need an answer operation for every n in length nums. If the value at this index is greater than the value at the next index, then decreasing count needs to increase, and decreasing count needs to eventually become 0. Then, okay, I think that's the logic. Okay, so do 7, 6, 1, 6, 1, 2, 4. Would this work? Do I need to have the nodes? Probably, right? Probably. So, maybe I keep track of a What if I kept track of a default dictionary where the node is the key and the prior node and the following node is in a list as the value of that key, rather than nodes where I wonder if that would work. I don't think that would work, to be honest, because I think I might need to modify the linkages. So like the 7052 needs to be relinked to 6124 as its following node if 5123 gets modified. I mean, I guess I could still change that. We'll change the link of the key. 5123, look at what it's linked to, change what it's linked to. Is there a better way of doing this? So anytime I'm thinking about n log n, I could possibly think about binary search. Given where you can perform the following operations any number of times. Like searching for the correct number of operations. Correct number of operations. Unfortunately, I think this is pretty constrained because there's going to be exactly one correct operation each pass, and that operation changes what the later passes might do in a kind of very dependent way. So I don't think I can just guess the number of operations and then see somehow that's the number. So if I go with this heap idea, I'd have 10 to the 5th number of things in the heap, and then some number of outdated stuff in the heap as well. And then we need to add modify, find the lowest element of the heap, remove it, modify the counts. It's kind of disgusting, to be honest. Disgustingly complicated. So I think if I use the heap idea, I'd need to have nodes here. Yeah, I think I might need to have nodes. Let me see here. Which node example do I want to use up here? Where are my nodes at? Okay. Let's go ahead and say linked node here. Um, Probably that's it. Do I need values? Probably the index. No, so I think I need to have a sum. Let's say self dot sum equals sum. Value should be the index. A left node, a right node. Do I need value 1 and value 2? Sure. Oh my god, this is so disgusting. Okay, so let's go ahead and try to create a linked list of nodes, or the nodes are the pairs of things here. So for every index in range, I think I want, generally for dummy nodes or for any sort of linked list, I kind of like a dummy node for the start. So let's say start is going to be a linked node. The sum is going to be, let's say, just 0. Index is -1, value 1 is 0, 0. And then it'll currently have nothing on the left or right of it. And I guess I'll do current equals start. No, I want to stay. I want to have a reference to it. So then for every value in the array here, I wonder, maybe the sum should actually be the first value in nums. The index is -1, the value 1 is 0, and the value 2 is nums at 0. That makes a little more sense. Okay, so for every index in range n-1, I'm going to say value 2 is equal to, actually let's say this node is equal to a link node. The sum is nums at this index plus nums at index plus 1. The index is this index. The value 1 is nums at index. Value 2 is nums at index plus 1. And then the left node from this is the current node, right? Or the current node is the prior node. And then I'm going to say the current dot right node. Maybe left and right are just not the right terms here. I guess I'll just use before and after. I mean, obviously, most people think about linked nodes in terms of going left to right, but in theory, it could be another orientation. So before is the current current.after equals this node. I think that's right. Okay, and then I need to check this. Do I need, I think this works for all nodes pretty much. So I'll just go, say current equals start, while current not equal none. Let's go and just print this things out. Current, print out the current. And then current equals current.after. Okay. Left is not defined. Very good. Yeah. Oh, this is not the correct number of linked nodes. It should be 3. Okay. Printing out the current obviously is not great. What is the to print objects fields and values in Python? I think there's an actual, is that info vars? Vars parentheses the object. Okay, so the start object is 5, 2. That's the start 4. Okay, I think maybe I forgot to actually say that the current is equal to this node now. That's my bad. Okay, so sum is, okay, the first one's the start, which is kind of the dummy one. Okay, 7 is the first pair. Index 0, first value is 5, second value is 2. And then the next one is sum is 5, index 1, value 2, 3, sum is 4, index 2, value 3, 1. Okay. Alright, so that seems like what I wanted. Actually, so then I need to have a heap for each pair. Actually, I think maybe I'll create the array of tuples, and then I'll just do heapify after I have all the tuples added. Contains tuples that are sum, index, value 1, and value 2. So I'll say heap.add or heap.append the tuple from this thing here. So it would be, oof, okay, fine. I think I need to just create values for everything. Sum, total, val1 and val2 is equal to nums at index plus 1. Total equals val1 plus val2. Total val1, val2. Heap append total index val1, val2. Maybe since I'm passing this into my, no, that's fine. I was thinking of just adding a call within the constructor here to add a tuple into the heap, but I think this is just a single time thing. Every other pass will probably be some sort of modification. Okay, so after I'm done here, I'll do heapify. Heapify heap, I think. That's the call. cpu.heapify parentheses the heap variable. Okay. So that should be fine. I also need to keep track of the decreasing count. I think I should probably keep track of the decreasing count here. So I think maybe after I do this, if val1 is greater than val2, decreasing count increments. Okay, I can move this. Current equals start. Start links up everything. I wonder if I even need a reference to start, to be honest. Actually, I forgot to look up. I forgot to. No, okay, actually. So the node is linked to the previous node by this reference to the current, where the current is the prior node. And then it changes the after. Okay, so I think all the nodes do have correct references to their before and after nodes. Yeah, before has a reference, after has a reference. And then the last node doesn't have anything after it, which is fine. Technically, maybe the first node might not need a reference. Yeah, it's fine. Is it fine? Maybe the first node just should not have a reference to anything. Yeah. Alright, I'm going to go ahead and say it's like current is equal to none, because it might screw up once I do the modifications. Okay. So decreasing count needs to be 0. So I think this should be while decreasing count not equal to 0. And then answer plus equals 1. And then return answer or something like that. That's kind of outline logic. Decreasing count not equal to 0. Okay. So I need to like take lowest node, which is the pair sum off heap, modify, adjust counts. Answer is just the number of times I have to do this. Okay, I think I need to also have maybe a set of valid tuples. Set of valid tuples. The values could actually be 0, huh? Okay, I think valid is a set of tuples. When I take a node, how would I even work this actually? So if you take a node, if you take, maybe the node in the heap needs to have the reference. Maybe the tuple in the heap needs to have a reference to the node. That might work. The reference on the heap needs to have the tuple on the heap has a reference to the node. Tuple on the heap has a reference to the node. Because I want to be able to immediately see what the nodes are. I wonder if that works actually. Indent. I think I should be able to add a reference to a tuple. Current.after equals node. When did this? Oh, current is none. That's right. Fine. Is it? Current.after equals node. I guess maybe I should say if current. Okay, yeah, I can add references to those tuples. Yeah, I think that's fine. So then I have the reference to those nodes. And then valid needs to just add this tuples without that reference, because that reference might, because the tuple itself is the tuple with just the previous stuff without the reference is what I really want to store here. Okay. Okay. So I'll take the lowest pair sum off the heap. So it should be total index val1, val2, and the node reference is heap dot or heap pop. Okay, so I have that lowest thing. That's the thing that I need that I should be replacing at this point. So the total is going to be replacing the prior node's val2, and the total replaces the following node's val1. Say before node is going to be node.before, and after node is going to be node.after. I wonder if I even need to create variables for that. Probably. Yeah, whatever. So I'm going to first make those nodes invalid. Is that what I want to do? First make those nodes invalid. Those nodes have some tuple information. So before tuple is going to be the tuple from the prior total, so it'd be like before node dot total dot sum before node dot index before node dot val1. This is just too long. I'll just do pre-node and post-node. Actually, it could be none if this was at the very start. So if pre-node pre-tuple pre-tup is pre-node sum, pre-node index, pre-node val1, pre-node val2. And then I do valid dot discard pre-tup. I think discard is the one that does not raise an error. I could use remove if I'm really confident here. I think discard is fine. So this needs to modify, right? Total needs to modify. So 3, 1 becomes 4. And this 4 needs to compare with the 2 to see if it changes the number of decreasing. Well, not just that. So, so if it was a 2 and it's a 3 here, so what could it possibly do? No, it could possibly be going downwards when you combine because it could be negatives. So the decreasing count. No, this stupid logic here. Ooh, I have a feeling I'm just gonna mess up this logic here. So val1 is gonna stay the same. Val2 is gonna change to total. So if val1 is less than val2, array is said to be non-decreasing. So decreasing count needs to be 0. Decreasing count needs to be 0. So if it's non-decreasing before, now it's decreasing, then that means it's a change. Or if it's decreasing, now it's non-decreasing, then it's a change. So it needs to be the comparison of val1 and val2, I think. So if it was decreasing before, so if val1 is greater than val2, pre-node val1 is greater than pre-node val2, and now it's not. And now pre-node val1 is less than or equal to this new value, which can be total. Then the decreasing count needs to be downwards adjusted. So this is decreasing. Val1 is bigger than val2. But now it's not. Val1 is less than or equal to val2, where val2 is the new total. Okay. And then the other direction is if prenode val1 is less than or equal to prenode val2, and now prenode val1 is greater than total, then decreasing count increases by 1. There should be a better logic for this. Heaven help me if I know what the better logic is. I think it's like, if I look at the signs, maybe if I did something where prenode val1 minus prenode val2 multiplied by something something, negative and positive, then it has to be 0 possibly. Decreasing negative negative. I wonder if I do some sort of bitwise operation on the direction of movement. I know that I'll just make a note here. There's some smart kind of bitwise logic that could simplify this. Smart being much smarter than me. Okay, anyways. So now, so that's the change in the decreasing count. So now I need to add the new tuple. I need to change the nodes. I need to change the nodes and add the new tuples. I need to modify this thing. So the node should be, oh, this thing, when I pop it off the heap, I need to check whether or not it's valid. If total index val1, val2, not invalid, continue. Okay, so valid append, I guess it should be heap push. Heap push. So the thing is going to be total, where the total is going to be total should be now that I think about it, maybe I shouldn't have all these. Maybe I shouldn't have all these extra values in the tuple. Alright. Thinking too much here. Heap push onto heap. Total, which should be total plus prenode dot val1. I combine this thing. So this thing becomes like a 4. So now the pair that is before this should be 2 plus 4, which is 6. The total plus prenode val1 index should be whatever the prenode index is. And then prenode val1 and prenode and total are the two values. And then the prenode is the reference to the node. And then I should say prenode dot sum is going to equal to total plus prenode val1. Prenode val2 should equal this total. And the prenode dot after should equal the current node dot after. Or I guess I should say post node here. I think that's the modifications I need. I also need to do the valid heap. Yeah. Valid dot add. It should be the total in the index. So maybe I'll just do it here. Valid dot add. It needs to have all 4. I need to have all 4. Could I just do total and index? Does that work? I don't know. I feel like I'm using too much information, or I'm putting extra information that might be removed. Anyways, valid's going to add in prenode dot sum prenode dot index prenode dot val1 prenode dot val2 at this point, because I've already kind of modified it here. Alright, and then same deal if post node post tup is going to be post node dot sum post node dot index post node dot value1 post node dot val2 valid dot discard this node this tuple. And then same logic for the comparison. Okay, so if if it's decreasing, that means that the value, if it's decreasing before, so that means that the value 2 is greater than post node dot value 1 and no longer decreasing, and total is less than or equal to post node value 1. Decreasing count decreases by 1, else if value 2 is less than or equal post node value 1. So it wasn't decreasing and now it is decreasing. Total is greater than post node value 1. Decreasing count increases. Okay. Heap push onto the heap. Total plus. Maybe I should do this first. Changing the pre-node post node. Post node dot sum is equal to total plus post node dot value 1 post node dot value 1 equal to total. Actually, what is sum going to be? No, sorry, it should be value 2. Post node value 1 equals total. I think that's right. Maybe the logic should better be post node dot value 1 equals total now. Post node dot sum is equal to, I guess it's still the same, post node value 1 plus post node value 2. And then post node dot before equals pre-node. And then heap push onto the heap. Post node dot sum, post node dot index, post node dot val1, post node dot val2, and the pre-node. No, and this post node reference. I think I want to make these two consistent. So pre-node dot val2 equals total. Pre-node dot sum equals pre-node dot val1 plus pre-node dot val2. Pre-node dot after equals post-node. And then heap push pre-node dot sum, pre-node dot index, pre-node dot val1, pre-node dot val2. And then pre-node reference. Heap push, and then I think this is all redundant here. The valid is not. Then I say valid.add the tuple that is postnode dot sum, postnode dot index, postnode dot val1, postnode dot val2. Okay, I think I forgot to, if I'm removing this node, which is this pair, I also need to change the decrementing count based on this. So if the val1 is greater than val2, and now I'm removing it, then decrementing count should decrease by 1. I don't know what this is. I think that's done. I think this is necessary. Okay. Let's see how badly this crashes and burns. post tuple, extra parentheses. Ooh, exciting. Let's go and just do a slightly more difficult test case. Let's say 10, 5, 5, 20, negative 50, 60, or negative 5. Alright, let's see how this goes. Index out of range. Interesting. Heap, pop, heap. So index out of range. I think that means that the heap is empty. The heap is empty. But the decrementing count should be eventually 0, because if there's only one valid thing in in all the jazz, then let's see. Uh-oh, SpaghettiOs. Let's go ahead and guess I should probably just print out, say, the answer in the heap each time. I don't know if this can be, this would be maybe too much information to parse. Yeah. So it did do 11 passes. 64. Interesting. I wonder if it automatically should assume that if there's only one element in the heap, then there's one element in the heap, then shouldn't the decreasing count be 0? Okay, let's go ahead and just do a simple one change and see if it handles one change correctly. I guess it doesn't handle it correctly. It does handle it correctly. How unfortunate. I was hoping there'd be just one change I need to make. Huh. 61, 64. The heck? 61, 64. I guess the 61 is outdated. 64 is not outdated. 61 is outdated because how do I know that? Because 64 is the last thing in the stack. Alright, what the hell is this? What is this? It's 59. It's not even the correct sum, huh? 64 versus 59. So somehow I got to 59 here. That was with 10. 59 there. And somehow on the stack there was 64 and 60. 60 I can understand maybe. 64 is maybe combining these two. 59. What's going on? Alright, let's go ahead and just print out the decreasing counts as well. Alright, so initially starts with 6 decreasing. 1, 2, 3, 4, 5, 6. Okay, so needs to remove all those. The heap has negative 30 at the top, which is the sum of 20 and negative 50. So it's going to combine those two. 20 and negative 50 combines to negative 30. Negative 30. So this is currently decreasing. So 6. When this thing gets removed, there's going to be 5 decreasing. And then when 520 becomes 5 negative 30, that's going to go back to 6 decreasing. And then negative 30, 60 is also not decreasing. So it should stay at negative 6, or it should stay at 6 decreasing, I think. Got to 7 decreasing. Unfortunate. 7 decreasing. That's not right, I don't think. 20 negative, so 6 decreasing, 6 decreasing. 5, 2, 1. 3, 1 is 2. 10, 5 is 3. 20 negative 50 is 4. 64 is 5. 4 negative 6 is 6 decreasing. So 20 negative 50 should be decreasing. So it should remove that. So there should be 5 decreasing. 520 to 5 negative 30 should make a new decreasing. So it should be 6. Negative 30 to 60 versus negative 50 to 60. That should be increasing. So it should be 6. So I think this is wrong. Definitely think that's wrong. If value 1 is greater than value 2. Oh, I see. Well, do I see it? If value 1 is greater than value 2, it's decreasing, I'm removing it. So therefore the decreasing count should decrease. I'm removing a decreasing pair. Okay, let's see if, just verify that that is what's happening here. Yeah, so it is removing the decreasing pair, so it should be going from 6 to 5. Pick the 5. But somehow the next pass it's 7. But somehow it's actually increasing decreasing count here and increasing decreasing count here. So let's see. Pre-node.value1 is less than or equal to pre-node value 2, and pre-node value 1 is greater than total. So that's fine, I think. If value 2, negative 50, is less than or equal to post node value 1, post node value 1 or post node value 2. I think this might be post node value 2. Yeah, I think I'm just using the wrong logic here. I think there should be post node value 2. If value value 1 is greater than pre-node value 2. So if it's decreasing before, yeah, this is just wrong logic. I think post node value 1 is greater than post node value 2. And now total is less than or equal to post node value 2, which doesn't change. Else if post node value 2 value 1 is less than or equal to post node value 2. So if it's not decreasing, but now the total is decreasing, post node value 2. Alright, just wrong logic. Okay. I knew I was gonna. Well, I had a very bad feeling about my logic there, or my ability to do that logic right now. But oh, let's give it a whirl. Well, that's a lot of cases passed. Anyways, let's go ahead and see what's going on with this one. Do. 2, 2, negative 1. Alright, I think I probably do need to print this. So it's answering much more than expected. Okay, so decreasing count should be the initial thing here. So I'm counting 1, 2, 3, 4. Somehow it's 5. 1, 2, 3, 4, 5. Okay, never mind. So it's 5. The smallest pair should be, the smallest sum should be these two. 2 plus negative, no. Smallest sum should be the 0, negative 1. Adds up to negative 1. The next 9. Okay, so if I remove this, the decreasing count should go down by 1. So 5 to 4. Okay. And now this is going to be -1 here. -1 plus 1 is 0. So the smallest sum pair should be 0, but it should be this 0. So it should be 0 index 4. Okay. That seems right. So if I replace that, this is not decreasing. 3, -2 to 3, 0 should keep the decreasing amount the same. So I think it's going to be 4 next time, 4 decreasing count. So it's actually 3. Why is it 3? -2 to 2 is not decreasing. So currently, removing a decreasing pair at 4. So there's 4 left over after this. If I remove this 3, -2 to 3, 0. Wait. So this thing is not decreasing. 3, -2. So this would be 3, 0, 1. 3, 0, 1 has 1 decreasing. 3, -2, 2, 1 is 2 decreasing. Okay, so it does decrease it by 1. So it does go down to 3 decreasings. 3 decreasing at that point is 2 to -1, 3 to 0, and 1 to -1. Okay, and then the next pair that can be added together is the 1, -1 over here. 1 plus -1 is 0. It's going to be 1, 0 now. 1, 0 is decreasing still. Versus, so the number decreasing should stay the same, 3. Next one is going to be the 1, 0, adding to 1 at the 2, -1. 2, -1 becomes a 1. The number decreasing should be 2 to 1 is 1 decreasing. So I think it should be the same number decreasing, so it should be 3. Oh my god, this is a lot of stuff. Wonder if I can somehow. I think I have to find a better way to print out what's going on here. It's too hard to read. I think what I can do is I'll just say define a helper function to print. Print out. Let's go ahead and take the node. And then while node, let's do, how do I print on the same line? I guess I just make an array. Array append this node dot sum. Is it node dot sum or node dot val? I guess I actually want node dot value. While node, actually maybe I'll just do the first value in the array. Array equals node dot value 1. And then while node, array appends node dot value 2. And then node equals node dot after. and then print out this array. So answer, maybe I just return the array maybe. And I'll do print out the top of the heap, something like that. Maybe I need to do this after checking that there is a heap. I don't know if this works. Probably crashes somehow. Line 45, missing parentheses. Tuple, oof. Tuple object has no attribute. Tuple object has no attribute. Oh, yeah, so the node is actually the reference, right? So, but I don't want to do this if it's invalid. So I guess I don't care. Maybe I do care. Maybe I should do this only after it's not right there. This is the reference to the tuple, and the tuple has the node as its 1, 0, 1, 2, 3, 4. Oh my god. Line 42. Node.value2. Array.append node.value2. What's wrong with that? No attribute append. Oh my god. Out of range. Really? Heap at 0? At 4? Heap at 0 at 4? Oh. Yeah, I popped it. I guess at this point it's just the node. Oops. Okay. 0, -1. What the fuck? Oh. What the F indeed. Yes, do it at the start, right? Fuck me. I could keep the reference to the starting node. Does that starting node ever... Could get discarded though. Starting node could get discarded. I wonder... Maybe I can just decipher what's going on using what's currently here. So the 0, 1 gets changed to be -1. Not great. It's not great. Because 2 and 2 get combined to be 4 at some point. 0, 1, -1 gets combined to be... Alright, let's just mimic it. Let's just mimic it. So first pass is going to be 2, 2, -1, 3, -2, 2, 1, 1. 1, and then this negative 1. This combines 0, negative 1. So this next pass should combine the negative 1 and positive 1, no, negative 2 and positive 2. So it'd be 2, 2, negative 1, 3, 0, 1, 1, 1, negative 1. Combines negative 2 and 2. This next pass should combine the 1 and negative 1 at the end. So it should be 2, 2, negative 1, 3, 0, 1, 1, 0. And here she combines 1 and 0, 0 and 1, 0 and 1. So that should make a 1 there. So 2, 2, negative 1, 3, 1, 1, 0. Combines 1 and 0. So it'd be 2, 2, negative 1, 3, 1, 1. Here she combines 2 and negative 1. 2, 1, 3, 1, 1. Combines 1 and 1. 2, 1, 3, 2. Combines 2, 1. 3, 3, 2. Combines 3, 2. 3, 5. So that should have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should have been 9. What's going on? 1, 2, 3, 4, 5, 6, 7, 8, 9. Non-decreasing. Oh boy. Zero, negative 1 combines to be negative 1. Negative 2 and 2 combines to be 0. Negative 1 and positive 1 combines to be 0. Zero and 2. Oh, it should have been combining these two first. Fuck. I wonder if that changes everything. So this should combine 2 and negative 1. So it should be 2, 1, 3, 0, 1, 1, 0. Now it should combine 0, 1. 2, 1, 3, 1, 1, 0. Combine 1, 0. 2, 1, 3, 1, 1. Combine 1, 1. 2, 1, 3, 2. Combine 2, 1. 3, 3, 2. Combine 3, 2. 3, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9 combinations. 1 combination gets here, 2 combinations get here, 3, 4, 5, 6, 7, 8, 9 combinations. Okay, that is 9. Guess how can I quickly, let's see, print out How can I figure out what I should be doing here? I think maybe if I just print out answer, decrement count, and maybe val1, val2. Sure, maybe that might be enough for me to determine when I messed up. Alright, combine 0, -1. Okay, then combine -2 and 2, 1 and -1, 2 and -1, 0 and 1, 1 and 0, 1 and 1. That thing combined multiple ones and ones, whereas I should have not needed to. Ooh, ooh, this is not good. Ooh, baby. I think this is... Uh... Okay, I think what's the matter here is just outdated information of nodes. Maybe? And this seems to me to indicate that I can just maybe keep track of the nodes that are relevant inside the heap. All the other nodes are updated. Is that true? Is that true? Then maybe I'm not fully recognizing what's going on here. 1, 1. Index 6211. Answer, decrement count, value1, value2. Guess I might as well print out the index where this is occurring. Index here is 6. And it's repeatedly using index 6. Interesting. Do I never change that this index is now not valid? Interesting. I wonder if this should just be, if it's invalid, then if it's not invalid, then continue, but then I don't know if I actually removed it from the valid list. Valid.discard this current tuple. Guess I can just say current tuple is equal to total index value1, value2. Valid.discard this current tuple. Okay, well, I think I had the correct sense of what was going wrong, but I don't know if this was the best way of handling it. Let's go ahead and just remove some prints here. Okay. Not the greatest. Not the greatest. But an answer nonetheless. Yeah, I feel like I'm feel like there should be a better way of tracking when things are being removed from the heap, or keeping track of which ones are outdated tuples in the heap and which ones aren't. I feel like maybe there's just either tracking it wrong, the tuples have too much information, maybe the tuples should only have the total and the index and the reference to the node. Total, index, and reference to the node. And then when I verify that it's a current valid tuple, that it should go to the node. Valid total index val1, val2. How do I verify things? Node. So many nodes. Take a look, pair some. I don't think this should. This shouldn't be necessary here. I think this was from a previous. Yeah, I don't think this should be necessary. Yeah. Good. Same speed, just without unnecessary code. Total equals index value1, value2 node. So the heap needs to have reference node in order for it to update. It has to have that. Once I remove that node, that pair, I update the two nodes to the side of it. I add the sum. I need to adjust the total. So the total changes. Total changes. So I wonder if the valid set could just be total and node. Total and node. Not anything else, because the node is linked to the index for sure. There's just no node is linked to the index. So it's kind of redundant. The node never changes its index. the node does change its neighbors at points because they get deleted. But when I'm seeing the heap and seeing if there's a valid tuple at the top of the heap, as long as that node's total is the current total, then that means it should be fine. So valid should just be the total. I can't use the node. I have to have the index because the index is the tiebreaker. It needs to be earliest. So total and index. I don't even need to have value 1 and value 2. Index is the same as the node. The index uniquely identifies the node. So let's go ahead and see if that plays out. So I need a value 1 and value 2. Don't feel like it. I think I just need the reference to the node, but let's go ahead and just delete this value. Just say I just store total index and based on this, the current tuple is just that. If that's not valid, then ignore, and then if it is valid, then discard. And then pre-tuple should just be the sum in the index. And then discard that. And then post-tuple should just be the sum in the index. And discard that. And valid should just do the sum and the index, adding it here and adding just the sum and index here. Okay, see if that works. I think I can clear out some more info, but just want to make sure that that doesn't crash before I move on to the next deletion. Oh boy. Index out of range. Oh yeah, so this is just, actually what is this now? Heap pop. Boy, why does this not work? Total index not invalid. So somehow heap is empty. But I'm still trying to pop. This is the same test case as before? No. Pre-tuple is sum and index. Oh, shucks. Okay. Guess I really couldn't do all that removal. Because I think what's the only thing that could be causing this issue is actually the the fact that that information was actually necessary to keep, because otherwise there's some sort of duplication of the sum index that makes it not the same if the sum is based on outdated information for value 1 and value 2. Why? How would that occur? Well, far be it for me to figure out all the combinations. Yeah, unfortunate. Unfortunate. So I think, yeah, I need to actually have that information somehow, because it does change what you consider outdated and what you consider up to date. Oh, that really sucks. Total index reference. Total index value 1, value 2. What if you just had the reference and then you looked at the reference? Total index value 1, value 2. Current tuple. This should just be if current tuple isn't in there. Now, whenever you can just store as a tuple comma node, does that work? Can you store a tuple inside a tuple? Yes. Okay, you can. Interesting. And so maybe I could just store the tuple information, that is the total index and value in the node. I guess that's probably okay. Okay, just do a little bit of reformatting here. Guess I don't need start, I never used it, right? Well, I kind of used it because it was, no, I use current equals, I use a check for the none. Tuple, link node. Guess maybe the node could just be the tuple. No, it's stupid. Heap.append. Let's see. There should be current tuple equals total index val1, val2. Append current tuple comma node. And this is adding the current tuple. And here it's just pulling the current tuple and the node. Oh, but I probably do need the actual information. I'll just remove it here. But yeah, I need to actually break apart this current tuple. So it's going to be total index val1 val2 equals current tuple. Unpack it. And then pre-tuple. Pre-tuple. Valid.discard the pre-tuple. Heap push. This just be pre-tuple and pre-node. And then post-tuple. Valid discard. And this should just be the pre-tuple. Oh. Yeah, so this is pre-tuple discard. Pre-tuple is equal to the tuple that is the pre-node sum, pre-node index, pre-node value 1, pre-node value 2. And then pre-tuple, comma, pre-node. And into the listing the pre-tuple. Alright, just double check this works. Maybe. No, this shouldn't work. It's gonna crash. Yep. Need to do more modifications here. Post tuples that. Post tuple heap. Need to create a new post tuple here. With some post node index, post node val1, post node val2. Then the heap pushes the post tuple, comma, post node. Valid adds the post tuple. Oh my god. Disgusting. Oh boy. This is quite disturbing. Not a crash, just a change in logic or giving a faulty logic. Where is it messing up? Current tuple unpacks. Current tuple node. Discard. Total index value 1. Value 2. Pre-node. Pre-tup. Sum. Index value 1, value 2. Discard. Change. Modify the pre-tup. Pre-node. 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 Push pre-tuple pre-node, add to the set pre-tuple, post node, post tuple discard, post logic for just decrementing the counter. Post node value 1, post node sum. Post node before equals pre-node. Post tuple, post node sum, index value 1, value 2. A push, post tuple, post node. Oh boy. Shucks. Why would this not work? Why? Current tuple equals total index. Alright, let's go ahead and just print out the valids, print out the heap, I guess. That's this one, print out the heap. 2, -1, -3, -1, 2, 3, 4, and 1. Okay, so that's all correct on the heap. 2, 0, 2, 0, 0, 2, 0, 0, -1, -1, -2, -2, 1, 1, 1, 1, 2, 2, 2, 2, -1. Okay. Guess I can just print out the valid as well. -3. 1, 2, 3, 4, 5, 6, 7, 8. This is 9 long. 8 pairs, so that's fine. Output 7, expected 8. What would be the matter? What would be the matter here? Link node, heap append, the tuple that is the current tuple. Heap pop. Valid add. Heap push. Pre-tuple. Has the tuple in the node. Heapify. Oh. Is it the sorting of the tuple that is not the same anymore? Can't imagine why the sorting would be different now. But that's the only thing that I can come up with. Sorting of the tuples is different if it's packaged. Okay, interesting. Well, I tried. think it's time to wrap this up. Not my greatest, not my worst, not my greatest. Yeah, it is what it is. So I can just say if current couple here. Move pre-node, post-node. Discard and add post tuple. Okay. Okay. Let's go ahead and check. Verify that this thing is still fine through all the crap and all the man, there's just yeah, that's not great. Just so not great. Alright, whatever. Summary here. Let's go ahead and guess Alright, summary. What's the summary here? So used a heap along with a linked list of nodes where each node kept track of a pair of adjacent values in terms of the sum, the index, the value 1 and the value 2. And as well as its prior and its prior and post nodes. Use the heap to find the smallest sum pair / node. Modified or remove that pair, or basically remove that. Well, first, as long as that node was still valid, performed operation, which is to create or exchange that pair with its total, with its sum, by modifying its pre and post nodes, kind of checking or changing their value 2 and value 1 respectively. Since the total now changes those parts as well as the sum. Also kept track of the number of decreasing pairs, decreasing count, pairs count, and had logic to modify that count based on performing this operation. Lastly, kept a set of tuples to verify that some tuple in the heap, where the heap has tuples of some index value 1, value 2, and node, I guess, yeah, is still valid, since those pairs might be changed in the process. So, I mean, it's a lot, unlike the other problems where it probably aren't as complicated, so I can give a easier summary that is more more descriptive. It's just a lot. So there's your node, there's your link node. There's the first bit where I'm just calculating, I'm converting all the information from the original array into kind of a list of tuples, tuples being the total index value 1, value 2, the node as well, the node being created from the information from index and index plus 1. There's that. It's all linked, right? So I have current.after equals node, and then changing the current to equals the node after I've made it. And then I have the valid set, where the valid set currently has basically everything except for the node reference that was added to the heap. Heapified, so now sorts it by, or finds the lowest total as the front of the heap. And then as long as the decrementing counter is greater than or equal to 0, which means, or it doesn't equal 0. So as long as there is some sort of some pair that's decreasing within the current values of the array, or the logic of the array, then this loop is going to keep on going. This loop will basically process the lowest valid pair, lowest valid summation. So it takes the top of the heap, which again sorts by the lowest total and secondarily by the index. So it's going to be correctly getting the front side if there's a tie. Gets to basically the tuple information of that, and if it's not valid, so it's not currently, yeah, it's kind of an outdated information, then it's going to skip it. Otherwise, it is valid information, so it discards it, so it doesn't go over it again. And then, so if I'm combining two values that are decreasing, so the pair of values is actually decreasing, and now I'm combining them, so that means that the decreasing count is now one less. And then if I were to perform this combination, then this total of value 1, value 2 modifies what would be happening with the previous pair and the later pair. So for instance, right, if let's say I'm combining this 0 and 1 into a 1, this means that the previous pair, which was 3, 0, becomes a 3, 1, and this later pair, which is a 1, 1, technically it stays a 1, 1. But anytime you combine two numbers, the nodes or the pairs that are before that and after that have the value 1 and value 2 as its second and first values of the pair, it needs to change because the total then replaces those values. So anyway, there's just logic for that. So I get the pre and post node from this node. I remove the tuple from the current pre-tuple, basically, from the VOD, because I will add something that's updated afterwards. Have logic to update the decrementing count, the count of things that are decreasing based on comparisons of how value 1, value 2 were before versus after with the replacement total. And then update the node's information, and then push the new information onto the heap, and then add it to the valid set. Same thing with post node. Update the decrement count, update the information from the node, push the new node information onto the heap. And then increase the answer because I've done one operation of combining stuff. Alright, time complexity, this is going to be O of n log n. Since the initial heapify is an n log n operation, and the main kind of loop does n repetitions, basically, where each repetition I misspelling where each repetition basically removes one pair, which basically eliminates one value from the array. And each loop can take O of n time, O of log n time, since it has heap pushes the new tuples, which is you're adding something onto the heap. That's where you're kind of there, so it's going to be O of n to insert a new value into the heap, which overall is n times log n, right? Alright, space complexity is going to be O of n, since the heap can have n pairs of tuples, which matches the number of pairs, which is like one less than the number of values in the array.